Hey everyone, welcome back to part two of test one naming. So in this, we're just going to go over some cyclic naming, go over some bicyclic naming, which is something that will probably also be on your exam, and doing some problem set practice. Some cyclic naming. So cyclic just means ring structures, and these can be as small as a 3-carbon ring, or all the way up to, I don't know, a 10-carbon. It can be as big as if Dr. Berg wants to give it to you, but generally knowing up to 10 should be okay for the rings. So just to start off, we have right here, that's a rough triangle, pretty small. Okay, so this is going to be, this would be a 3-carbon structure, but since it's in a closed ring, we're going to add cyclo, and then the same ending, propane. So one thing that's different is that when it's a fully closed circle or structure of any kind, you're going to add the word cyclo. And this works the same for butane. So we'll have a little square right here, and this is going to be cyclo butane. And this would work the same up like going through pentane, hexane, and all of those structures. So let's do a little practice down here with some of these structures. So this first one, numbering can be a little bit difficult on ring structures, but in this case, we have an alcohol, which immediately is going to give us that 1. But we can also go, so we have 2 different directions we can go. 1, 2, 3, 4, 5, 6, or we can go 1, 2, 3, 4, 5, 6. So in this case, it comes down to alphabetical order. And the bromo, once again, comes before chloro. So we're going to go with the purple numbering, which is our 1, 3, 5. So we're going to have 3 bromo, 5 chloro. Now always remembering to drop the I and E off of the halogen name and add in the O. And then we're going to have our 6-carbon ring, so that's a hexane. We're going to have cyclo, X, and once again, with anything that has an alcohol, we're going to drop the E and 1 all. Like I said earlier, with ring structures especially, you can drop the 1 since it's redundant and the alcohol is always going to take priority. So it's always going to be the 1 carbon in this case, but you can also leave it. I prefer to leave it personally just so that I know that I have a number and that I know where everything is. So that's our first one. Move on to our next one. Once again, we have a 6-carbon ring right here. So we'll start numbering one direction at the bromo. So 1, 2, 3, 4, 5, 6. And then we'll start numbering from the fluoro. 1, 2, 3, 1, 2, 3, 4, 5, 6. So either way you go, it's not really going to matter number wise. But once again, you have to look at the alphabetical order. And we're going to want to start at the bromo. Just because its alphabetical order is higher, so we're going to go with the 1 for numbering system. So 1 bromo, 4 fluoro. So again, cyclo. And this time we don't have an alcohol present, so it's just going to be cyclo X, a normal ending, normal name, nothing changes. So here we have a cyclopropane. This time we have 2 groups, and we want to look at the alphabetical order of these groups since neither one of them take priority since they're just branches. So here we have a methoxy, or not a methoxy, a methyl. And here we have a proxy. All right. So alphabetical order-wise, the methyl group's going to come first. So we're going to start our naming up here. We're going to go 1, 2, 3. So we're going to have 1 methyl, 2 propoxy cyclo, and like I said, it's cyclopropane, same ending, nothing changes. There's no other functional group or anything to change the ending of the parent molecule. All right, that's pretty much it for the cyclic naming. Definitely practice, do the textbook problems, look over the practice tests for different examples of the cyclic structures, do the problem sets. Very helpful for all of that. But now we're going to move on to bicyclic naming. Now, bicyclic naming can be a little bit confusing. It's very different. We have 2 ring structures combined, as you can see right here. But so some of the tips for naming these. So right here, these are the bridge heads. And this is where you start numbering. So always start numbering at a bridge head. So you couldn't just go and be like, oh, I'm going to start naming there. That wouldn't work just because you have to start at the bridge head or else the numbering will be off. Now with that, you also can't go like 1, 2, 3, 4. You always have to go around the largest ring first. So in this case, you would go around this ring before the smaller ring. But while doing that, you also want to make sure you're looking at the groups and try to keep the lowest numbering system overall. So with this first one, we can start our numbering. So our bridgeheads are these carbons right here. And so we can go, we'll try 2 different ways to see what we get. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. So that's that. Then we also have 1, 2, 3, 4, 5, 6, 7, 8. So in this case, our red numbering system gives our methyl group right here the lowest numbering convention. So for our name, we're going to start off the same as with any group. So 7 methyl. And then this is where it gets a little bit weird. So instead of saying cyclo or anything like that, we say bicyclo, showing us we have our 2 cyclic structures together. And then for the numbering, so in this one we have 1, 2, 3, 4 carbons. So we'll have a big 4 there. And over here we have 1, 2. So, and then in the middle we have no carbons, like right here, connecting them. So with that, it's going to go like this. We're going to have brackets. And the big ring goes first, so 4, 2. Those are periods after those numbers, 0, and then close the brackets. So that kind of shows how many carbons are on each ring right there. And then to finish off, we just look at the total number of carbons, which are 8 carbons for this one. So that's going to give us octane. So it's going to be 7 methyl bicyclo 4,2,O octane. Not too bad, nothing crazy there. But now we're going to move on to another one. So here we have two rings of the same size. Once again, we have our bridgeheads. We're gonna go right here, right here. Then we're gonna number. So we're gonna start 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And the reason I went around that ring first is because we have the alcohol there. And I'm gonna do the same thing. This way we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So with that, we have to look at our numbers. So we either have a 5, 9 system for our groups, or we have a 2, 8. And so automatically we know that alcohols are that priority functional group. So our 2, 8 group is going to win, but it's lower and also it gives the alcohol the lowest number possible. So we're going to go with that. But first we're going to look at the number of carbons. So each of these has 4 on the outside. Once again, with nothing in the middle, right there. So we're going to start naming now. So this one's going to be, and look at our first group. So we have 8 fluoro. We're going to add bicyclo. And once again, we add our brackets in. This time is going to be 4, period, 4, and then O once again. And we're going to close our brackets. And now we need to look at how many total carbons we have. So with our purple numbering system, our highest number is 10. So for 10, we're going to have decane, but we have an alcohol in this molecule, so it's going to be dec. Let's see. Dec. And it's on the 2 carbon, decane 2 all. So these are a little bit more complicated. They do follow the same convention every single time though. You start numbering around the largest ring first, always starting at one of the bridgeheads in between the carbon cyclic structures, and then just putting the number of carbons that each one of them has into the brackets there in the center, and it all works the same every single time. I went over this just to kind of give you a little practice and some information about it because it'll most likely be on your exam. Another 2 points that you definitely want to try to get. So it's good to just kind of like see these now. You can understand them and get some practice in. So we're gonna move on to our last little bit of practice for this video. We're gonna go over what your problem set looks like. None of you should have this group, but if you do, then you get some free help. So we're gonna start off going over the tips. So we're just gonna start by highlighting our longest carbon chain. We go 1, 2, 3, 4, 5, 6, 7. And we can kind of look around and see, like, do we have any other paths we could go that, this would be 1, 2, 3, 4, 5, 6. It's not quite as long. So we're going to stick with our 7 carbon chain right there. And everything else is going to give us a 6. So with that, we're going to number. So we're going to have 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. So we have a 3, 4, 6 system. And then we also have a 2, 4, 5 system. So with that, we're going to prioritize 2, 4, 5 because you have that methyl group right here on the 2 carbon. On that 2 carbon, and that system is a lot more favorable than our first group B on the 3 carbon. So we can start A lot of times it's easier to break up your naming by pieces. So if we do that here, we can go with 2,5-dimethyl. It's one group. And then our ethyl group is on our 4 carbons. So we're going to have 4-ethyl. And then our parent chain is a heptane. So we go heptane. This is definitely a lot easier for the problem sets. On the test, you can still write it out this way and then combine them, but it's very easy to then just go and move the pieces around. So alphabetically, we're going to have our ethyl in the front, our 2,5-dimethyl right there, then our 4-ethyl 2,5-dimethyl heptane right there. So then moving on to our next one, we're going to do the same thing. And we're just going to highlight our longest chain. So we're going to go 1, 2, 3, 4, 5. Let's do it a little smaller. 1, 2, 3, 4, 5. And see, we can look at other directions. You have a 4 chain that way. Nothing else is going to give us anything higher. So we're going to stick with our 5 chain right here. Now we're going to number. So we're going to have 1, 2, 3, 4, 5. And we're also going to have 1, 2, 3, 4, and 5. We kind of want to look like where the groups are. We have a group here on that carbon, another group there, and a group there. So red, it's going to give us a 2, 3, 3. Sorry for that. And then we're going to have purple being a 3, 3, 4. So we're going to go with our red numbering. And so we have 2 methyl groups and a bromo group. In this case, we're going to want our bromo group to go in front. This is alphabetical order. And then our 2, 3, once again, dimethyl. And then this is a 5-carbon chain. We will have pent chain. We're moving on to the next one. And in terms of difficulty, this problem set compared to the test, I would say is a little bit easier than some of the things you might see. Some of the things we'll talk some more in class about different kind of problems that I mentioned in the video with like alcohols and amines together, methyl groups on the amines, diols, things like that, the bicyclic compounds. So definitely just be practicing as much as possible, like I said earlier. So we have our longest carbon chain. Now we're going to number once again. Naming is all about numbering. It's the most important step, making sure you get those numbers right and as low as possible. So we have the red system that way, and then we'll go in purple, 1, 2, 3, 4, 5, 6, and 7. So let's see. So we have a 3 and a 4. And in red, we have a 4 and a 5. So we're going to go with that purple numbering scheme. So here, we also have, again, have a bromo and a methyl group. So we're going to go 3 bromo, 4 methyl, and then we have a 7-carbon chain, parent chain. That's going to be a heptane. Not too bad with that one. So now it gets a little bit more complicated. This is a ring structure. They're usually a little hard to number because you really have to pay attention to the alphabetical order when you're going around. So we do have a priority functional group. And we're going to start our numbering there. So red, we're going to have 1, Add a little bit. 2, 3, 4, 5, 6. So we have a hexane, a cyclohexane here. And then purple, we're gonna have 1, 2, 3, 4, 5, and 6. So red gives us a 1, 2, 6, and purple also gives us a 1, 2, 6. But purple gives chloro the 2, and chloro comes after bromine alphabetically, so we're going to go with our red numbers. So with this, we're going to have 2 bromo, 6, looks like a B, 6 chloro, and then we're going to have our parent name, cyclohexane. But in this case, we have an amine group, so we're going to drop that E on the hexane, go to hexane, and then hexane 1 amine. Like I mentioned earlier, you can absolutely leave the 1 out in this case, just because it's on the 1 and it's going to be there, and it's technically redundant. But I always like to do it just to be safe. So our last problem that we're going to be going over, this one right here, we're going to look at the longest chain. So it looks like it's this 6-carbon chain right there. Then we're going to number. So this one has a couple groups on it. We have a chloro, a methyl, and an alcohol. And this kind of problem is more like what you see on the test, having multiple groups, making sure that you know how to number correctly, knowing the alphabetical order stuff, and all the different conventions for dropping letters for the branch status versus the functional parent chain status. Then the other way, going 1, 2, 3, 4, 5, 6. So let's see, we'll look at those numbers. So the red, we get a 2, 3, 4. Doesn't look too bad. Purple, we get a 3, 4, 5. So looking based off the numbers alone, the red would be ideal. But that alcohol group right here, the red numbering system gives it a 4, and the purple one gives it a 3, and that 3 is what we're going to give it. Alcohols always want the lowest number possible, even if it makes other things have higher numbers. So we're going to go with our purple numbering system right here. To start off, we're going to have our chloro, just based on alphabetical order. So our 5 chloro, 4 methyl, and then we have a 6-carbon chain right here. So we're going to go hex, ane, drop the E, hexane. And in this case, the number is very important to note where the alcohol is. Since it's not on the 1 carbon, you have to include it 100% of the time. We're going to have hexane 3-all. So that kind of concludes all of the practice and the notes on naming for test 1. This video is relatively comprehensive on most of the things that you need to know for naming, at least for right now. The problem set will look just like this one. Might have a couple different problems, but everything in the video that I went over should be able to help you complete that now, even if Dr. Berg hasn't covered it in class yet. So watch this video, practice, do the problem sets like I said earlier, do the practice test, and make sure you come to our review session next Sunday on the 22nd. I believe it's at 7 p.m. Well, we'll provide more information about that in class. Yeah, if you have any questions about any of the things in the video, feel free to email me, come to any TA's office hours, ask questions, choose the group me. Definitely reach out for help before it's too late. But good luck studying, and I will talk to you all later.